Hi everyone and welcome back to my channel. So we are in the 17th video of this series on social information networks that I have recently started. So in the last few videos, we've been discussing all the important concepts of social information networks, and social information networks itself is a very important subject in the computer science and engineering degree. So now let's get started with today's video. In today's video, we are going to discuss something called Jaccard's similarity. Now, what is Jaccard's similarity? Jaccard's similarity is basically a measure which helps us understand which nodes are closer to each other and which are not that close to each other, right? So, or rather, which clusters are close to each other, or so now what is Jaccard's similarity? So Jaccard's similarity is basically a measure that helps us understand how close two sets are to each other. So now what is Jaccard's similarity? Jaccard's similarity is basically a measure which helps us understand how close two sets are to each other. Okay, so it is basically the distance between two sets or two documents. Okay, so now let us understand this with an example. So let's say we have two sets A and B. A has 5 elements 0, 1, 2, 5 and 6, and B has 2, 3, 5, 7 and 9 elements. So total of 6 elements, 5 and 6. Now, how similar are A and B? That is, how close to each other are they? So we have this formula of Jaccard's similarity, which helps us understand how similar they are. This is one of the measures that can be used. So Jaccard's similarity of A and B is defined as A intersection B, modulus of that, divided by the modulus of A union B. Okay, so basically you are understanding, you are finding out what are the intersection or what are the common elements of A and B, the number of common elements. So A intersection B is basically the set of common elements. The modulus or the absolute value denotes that it is the number of common elements. Okay, similarly A union B is basically the set of all elements from between A and B, and the modulus suggests that it is the number of union of elements. Okay, union of A and B, union of A and the elements that are there in the modulus suggests that so the modulus suggests that it is the number of elements in the set of A union B. Okay, so now A intersection B has what all elements? 0 is common. So A intersection B has what all elements? 0 is common. Then A intersection B is basically the common elements between A and B, right? So 0 is common, 2 is common, and 5 is common. The magnitude or the absolute value of this is what we want. And in the denominator, we have 0, 1. Union is all the possible elements that are there in A and B. 0, 1, 2, 3, 5, 6, 7, and 9. Right. So the magnitude implies the number of elements. So this implies numerator is 3 and denominator is 1, 2, 3, 4, 5, 6, 7, 8, which is equal to 0.375. So this is basically the value of Jaccard's similarity between these two sets. So this is how you calculate Jaccard's similarity for a set of for two sets given. Right. Similarly, if you have, let's say you have two documents, this is the real-time use of this Jaccard similarity. So let's say you have two documents. Document 1 says I am Jishnu, which is my name. Document 2 says I am amazing. Now, the first step to calculate the Jaccard similarity between these two documents is to convert them into sets. So, there's something called n-grams, that is the number of set of words or the number of words that you consider as one element. So we will be using a 1 gram here, which means that each element in our set would be only one element. Okay, so I is one element, am is one element, and Jishnu is one element. Okay, and in the second document, I is one element, am is one element, and amazing is one element. So for this, the Jaccard similarity of document 1 and document 2 would be basically document 1 intersection document 2 divided by document 1 union document 2, which implies that the set of intersection would be I and am modulus, divided by you have I, am, Jishnu, and amazing, modulus of this. So what would that be now? The numerator has 2, so it is 2. Denominator has 1, 2, 3, 4. 4. It is equal to 1 by 2. It is equal to 0.5. So the Jaccard similarity score between document 1 and document 2 is 0.5. So this is how you calculate the Jaccard similarity between two documents or two sets. And that's all I had for this video. I hope you got to learn something, and if you did, please do like, share, and subscribe to my channel. And thank you for watching. Stay tuned for the next video.